2 servos to drive the 2 degrees of freedom at the knuckle joint. To make the fingers move, we have to add motors, of course. These are the equivalent of muscles in animals. So the name for this kind of little motor is a servo. These are particularly slim ones, and this has a torque of 2.4 to 2.8 kilogram centimeters. And what is torque, you might ask? What torque is how hard you twist something. You twist a door handle, that's torque. And that number there, you've got 2 numbers because it can run at 2 voltages, 4.8 volts up to 6 volts. And at those 2 extremes, you get a torque of 2.4 and 2.8 kilogram centimeters. And what that means is if you put a little arm on the side of this, which of course you can do because servos always provide little packs of plastic, what are called servo horns. If you clip that on there and you measure from the center 1 centimeter, which you can see in fact is just between those 2 holes, something like that, from the center, that is a centimeter, then it will lift 2.8 kilograms. If it was putting something up by turning this way, it would lift 2.8 kilograms just there. And that's what torque is. For the V1 DexHand, the servos that we use are made by Emax, and there's a whole family of them, ES33s. The 5.2s are the top of the range, the most expensive. They come in around about $12, I think. And you're going to need 2 per finger. So as an example, we're going to start with the first finger because it's a standard size. And the servos mount very simply by slotting in to those gaps and then screwing down. So you've got a gap here, so that means there's another one which goes for back underneath it. Now the easiest way to check what I'm doing is just to use the previous one, because clearly that one works. And you can see that on the forefinger, they're both pointing away. As in, the servo horn is away from the finger. One's going to go there. One's going to go there. Just check that everything still moves with the long tendon like it should. These are going to drive tendons which run through here and up to the knuckle, and that will cause pitch and yaw motions at the knuckle like this. Tendons actually attach in a very simple way. They pass through a pin, the loop of it, pass through a hole back on the servo horn, and simply get wrapped around the same screw which secures the horn to the servo. Tighten everything up, stays in place. The horn itself doesn't have quite the right shape, so there's an additional printed component, and that simply gets glued on underneath, pressed and glued. And using super glue, always have tissues ready. It's just a stuff which gets everywhere and is a pain to get rid of. Make sure this is dead flat. Just give it a little couple of figure eights on the diamond plane. dotted glue in each of these corners. And just push it onto there. You can see the holes are exposed to thread the tendon, and that will hold on nicely. Filing, or rather than sanding the surface flat, you turn it in figure eights, and ideally you rotate it a little bit with each one that you do. That is how to grind a flat surface, so I was told. Don't lose these little screws. They're M2.5. It's a slightly weird size to find. Do a couple more while I'm at it to make sure I got the filming done correctly. Don't want too much super glue. Right, now I've emptied out our bag, we can also get to the screws. You're going to need 3 to hold these servos in place because 2 of the holes overlap. But you only need 2 because one of these is replaced by the longer screw which secures one in the middle. One there, and then here we have 16mm M2 countersunk. Okay, so that's the motor secured. They pull, of course, on the inside. So, now, to make sure that these are in the correct position to start up, you have to connect them to a radio receiver of some description. And then we have to power that with a handset. I'm not going to go into how to pair these things up. It's not as straightforward as it should be, in my opinion.
Welcome to OpenTX. Throttle warning.
Got a solid green light here. That means it's working. Connect one of them to 2. maybe 1 to 3. And there you see we have movement. Again, using this as an example, we can see that from this side it just winds here, and this side it winds on the other side. So they move in opposite directions. So if we place on, that's the radio gear you can hear. When the finger is fully extended, this one wants to be rotated around this way, this one wants to be rotated around that way. Like that. Because moving them this way causes it to contract. So move it up into that position and then pull the power.
Receive it.
Now, from these positions, we need to add some tendons, which pass through these little holes here, which we're going to line with PTFE, 1x2 standard stuff, and up to the knuckles. One up to there, one round to there. The other thing is whether or not you can actually get it through a 2mm hole. The way to deal with that is to cut it slightly longer than you need it. And then to stretch it out under heat. So you can tell it's going up to temperature because it goes transparent. And you can draw it out. And now I have a nice thin front. That you can stick through holes and pull. The advantage of that, of course, is that the Teflon won't slip. There we go. And you just cut this. Just where it's going to come on. So it'll wrap a quarter turn, pass up through this hole, and then be secured. So you can push that one all the way down. It's important not to lose these little screws. Now we just need a length of tendon. Use the same stuff as for the long tendons. I guess you could probably get with a slightly thinner one here as well. Length is no more than that. Trim it, and as always, be careful to try and get a nice clean edge. So having cut your loop, having cut your line, as always, just make it into a little loop. This will pass backwards through that slightly flared opening. A little bit of resistance because they crossed over. Let's see if we feel that's good enough. Okay, now that's starting to lighten up as everything gets bedded in. I think that'd be just lovely. Simply push this pin here out of the way. Be very careful not to slip and stab yourself with the screwdriver, because I can assure you that hurts. you can see already that when you pull that tendon, the finger moves. Very simple. It's easier, I guess you can pop that off. So easily just go through here. Now this servo position corresponds, I see I've got a twist in here, that's what we don't want. So as always, make sure that things are not twisted over. This corresponds to the furthest possible position that the finger could be from that servo, which in this case will be all the way over here. And with just a little bit of slack in the line. And the way I find to secure these is not to just wrap it round, but to actually wrap it back under itself. So effectively you just form a little loop like that. That means that as the screw tightens, it will also lock the tendon in position. So make sure the fingers are crossed, there's a little bit of slack on there. And then just tighten this up, holding on as much as you can to all the tendons so everything stays in the right place. You can always change it if need be, but that should lock it pretty well. Same thing on the other side. Slightly longer length of tendon. And then this Teflon from here to here. Maybe pull that one a bit too soon. We should see if that's strong enough. Oh, and yes it is. Just trim that through. As you can see, the problem is going to be this bit of curvature on PTFE. PTFE is a plastic very prone to creep. But it's also very easy to modify. Okay. So we have a loop of tendon, we have our PTFE in place. Place the loop over where the pin will be, push the pin through. Flare open the end of the PTFE. Actually, that's probably even better than the other one. Now you can see pop that off, it's easier in fact. goes through there. You want about a quarter wrap. Pop it down. Make sure these are not twisted as you pull them in. That would be across to there. And yep, same way again. Bit awkward, a bit too short. Still, make your loop. Start the servo screw, pull it round, screw down a little more, make sure that's in the right position. Seems really even. And then lock that off. Now, when we apply power, this finger should pop up towards us. Let's see if that happens.
Welcome to OpenTX. Throttle warning.
Okay.
Telemetry lost. Telemetry recovered.
So that diagonal causes them to move inwards. So that's pitch across that diagonal, and that's yaw across that diagonal. Two servos to drive 2 degrees of freedom at the knuckle joint. So simple.